Okay, question 6 says, find the direction and magnitude of the force with which the person at C, which is right here, must pull so that no one moves. So in other words, the system is in equilibrium. Okay, now up above here, I've copied the vectors F1 and F2, and we're told that F1 has a magnitude of 96 pounds, and F2 has a magnitude of 68 pounds, and we're given these two vectors 45 degrees and 30 degrees relative to the horizontal. Okay, so I'll start out by just finding component expressions for F1 and F2. So I'll write these in terms of the basis vectors I and j. And so just as we did in the last video for questions 4 and 5, okay, I can consider these right triangles you see here. And so for F1, noting that it's pointing off to the left, so its I component will be negative. I get negative hypotenuse, that's 96, times the cosine of 45 degrees. Okay, now for the j component, well, that's positive, right, pointing up, and so that's going to be 96 sine of 45 degrees. Okay, so now that simplifies to negative 48 root 2i plus 48 root 2j. Likewise for F2, noting that it's pointing off to the right and up, so both its I and j components are positive, we get 68 cosine 30 degrees I plus 68 sine of 30 degrees j, and that simplifies to 34 root 3i plus 34j. All right, so now the next thing to note is that if the system is going to be in equilibrium, okay, that means that the person at C has to apply a certain force so that what? So that the sum of all three force vectors is the zero vector. So in other words, there's no unbalanced force in the system, okay? And so that's equivalent to saying that F3 is minus F1 minus F2, and now using these expressions that we derive for F1 and F2 above, we get that F3 is 48 root 2 minus 34 root 3i minus 48 root 2 minus 34j, which comes out to be approximately 8.993i minus 33.882j. Okay, so now you'll notice that my F3 is actually pointing off a little bit to the right and down, and that's because the I component is positive, right, and the j component is negative. Notice that does not agree with what we're seeing in this picture here. So that might make you pause and say, oh, maybe we've done something wrong. Well, no, we haven't done anything wrong. The thing you have to keep in mind, I took this figure off of MyMathLab. Okay, now what MyMathLab does is they use a stock image and then they just randomize these numerical values. So they randomize the angles given and the magnitudes of these two vectors given. Okay, so for certain values, it's perfectly possible, like we just saw here, to actually get an F3 with a positive I component. And so this stock image, in fact, can be misleading. So do keep this in mind when doing homework, that you very well could have done the problem correctly, but it's just that because of this whole stock image issue, it may make you pause and think you've made a mistake because your answer is not aligning with what you see in the figure. All right, well, that's going to do it for this video. Thanks a lot.